All right, great. Hello, I'm Nicholas. I'm the co-founder and CEO of Opus12. We've developed a profitable solution to carbon emissions. So our technology converts CO2 into chemical and fuel building blocks. So you can, the three co-founders we met at Stanford in grad school, Kendra and Natasha, their PhD research was on this class of nanomaterials that can be used as a catalyst for converting CO2 into new products by applying current through that. So the way we got started was in the beginning of 2016. We were selected by the US Department of Energy to be incubated at Lawrence Berkeley National Lab. That's where we built the first prototype. Since then, we've raised cumulatively about $25 million, and we've built our first commercial system, which is converting CO2 into CO, which can be used as a building block for materials like polycarbonate, isocyanates for polyurethanes, obviously can go into methanol. It's kind of a very versatile molecule. The next product we're developing, we already have a prototype for it, is to make ethylene. So we're going pretty far upstream. And the idea is that we can just bolt into an existing chemical and material manufacturing process with no change to the product specifications, but we're just changing where the carbon comes from. It's coming from CO2 and water instead of from fossil fuels. So we've been backed by a number of venture firms, but also Shell has been funding our CO2 to CO work. We also have a product around CO2 to methane, which SoCal Gas has been sponsoring. And we do have a project to turn our methane into PHA in collaboration with a gas fermentation partner here in the Bay Area. So kind of the idea is we'll have a broad platform. We stay upstream with the kind of initial conversion step, and then we partner with others to deliver the final materials. So what we're doing is kind of like industrial photosynthesis. We're taking CO2, water, and renewable energy, and we produce oxygen as a byproduct, and then new carbon-based products. We're focused on these three to start: CO, ethylene, and methane. The CO2 impact of doing this, there's kind of two factors there. So you can think of the first part is we're actually using CO2 as a feedstock. So that part of your material is essentially carbon negative. So for ethylene, for example, we actually consume 3.1 tons of CO2 to make 1 ton of ethylene. For CO, it's about 1.6 tons of CO2 per ton of CO. So that's kind of the first factor, and then you are avoiding emissions relative to producing ethylene or CO in the conventional way. So the total addressable opportunity is like for ethylene, like 5 tons of CO2 per ton of ethylene. So you can imagine a wide range of materials and fuels that could be made from CO2 and still having the exact same performance and the exact same production technology that they have today. You can even think about this as a new way to kind of expand circularity or expand recycling. We are just recycling the carbon, so you're not limited in, for example, with polycarbonate, you can only get to about 50% recycled material without losing some of the nice optical properties. With this, we can turn any source of carbon into a brand new source for virgin material. So this is just, we drop into an existing chemical process, we're all the way upstream, so very little operational change. Our core technology, we're reprogramming an existing electrolyzer design, which is usually used to make hydrogen, with our internal component, which basically turns it from a water splitter into a CO2 splitter. And we've partnered with the world's largest manufacturer of these systems, and that's what our first product looks like. It's just their unit with our internal component, and it shows this really clear scale-up pathway and a really high reaction rate. We convert CO2 at the same rate as about 37,000 trees. So short on time, we'll talk about our partners after, but here's the team. Very happy with our very first commercial unit earlier this year. We'll start doing on-site pilots next year. We're developing capability for demonstrating polycarbonate production this year, isocyanates early next year, and naphtha as well. We'll have ready by 2021.
Well, we have time for a few questions. Going once, going twice. Got it.
For the PHA, I mean, what's your general cost estimate for producing that versus other methods at a CO2? How much per pound?
I'd have to get back to you on that because we're only part of the process. So we can be competitive with the biogas component of it. They're downstream relative to other PHA methods. That's more of their technology.
you guys as a technology licensor, or what's your business model?
So the unit gets installed at the customer site, and then we sell there's our core technology is this membrane that gets replaced on a regular basis.
How much are you looking to raise?
So we're not currently fundraising. Our next round will be our Series A. That'll be about a $20 to $30 million capital raise. That'll kind of fund these on-site pilots we're doing, and then scale up to an industrial size unit. When I say industrial size, I mean something that's kind of a shipping container sized unit that's producing several tons per day of CO.
All right. Thank you, Nicholas.
All right.